here I have a picture of the ratio 3 to 4. I have 3 circles on the left and 4 squares, so the ratio is just 3 circles to 4 squares. What exactly is a ratio? The definition is not very enlightening. A ratio is really just a ordered pair of numbers, just written with a colon in between them. You also want at least one of the numbers to not be 0. So ratios, whenever you have three circles to 4 squares, you get a couple of ratios that kind of come out of that. So there's the ratio 3 to 4. There's the ratio 4 to 3, coming from 4 squares to 3 circles. Remember, ratios are ordered pairs, like the order actually matters there. And you could also get the ratio 3 to 7, where you have 3 circles to a total of 7 shapes, right? Or you could do 4 to 7, where you have 4 squares to 7 shapes. So these are both examples of part to whole ratios, where the previous examples that we had were part to part ratios. So part to part ratios, there's 4 parts squares to 3 parts circles, whereas over here we had 4 parts squares to 7 parts for the whole. So let's see an example, correct? So let's say that we have a recipe which calls for 3 parts soy sauce and 2 parts sesame oil. That's part of the recipe. Let's say that we have 6 ounces of sesame oil in our cupboard, and we want to know how much soy sauce do we need to make as much of this recipe as we can. Right. So here I have a picture representing soy sauce and sesame oil. So the squares represent soy sauce, and the circles represent sesame oil. So there's a couple ways that we could visualize solutions here. So if we have 6 ounces of sesame oil, we know that 2 parts make up the recipe, right? So how many times does 2 go into 6? Goes in there 3 times. So one way of visualizing this is, well, you could just say that each of these parts, every single part here is going to represent 1 ounce. Okay, so if each of these shapes represents 1 ounce, I have 6 ounces over here, and I have 9 ounces of soy sauce over here. Right, so the picture looks a little bit weird, but here 1 ounce is representing the size of everything here. So the parts don't really look equal, but we do want to assume that they actually are equal, that they're all 1 ounce. Okay. So we would need 9 ounces of soy sauce that way. Okay. Another way that you could visualize solutions here is to just say, well, what does each of these parts have to represent? So before we were saying each part is 1 ounce, but we don't have to say that one part is 1 ounce. We could say that one part is 2 ounces or 3 ounces or 4 ounces or whatever we want it to be. So if we had 2 parts sesame oil and we needed to make up 6 ounces, then we can make each part worth 3 ounces. And so we have every single part for the sesame is 3 ounces, and then same for the soy sauce. So 3 ounces times a total of 3 parts equals 9 ounces. So that's another way of sort of visualizing the solution here. So that's sort of getting back to the definition of multiplication, how many groups versus how many in each group. It's very similar to that whole thing. All right. So notice that we get so another ratio over here. So the ratio that we get over here, I wonder if I can bring back. Yeah, there it is. Okay, cool. So here's another ratio over here. So this ratio is the ratio 9 to 6. And before, we had the ratio 3 to 2. Okay, and so both of these ratios sort of represented the same sort of thing. So if we said that our recipe was 9 parts soy sauce to 6 parts sesame oil, that wouldn't have really changed the recipe at all. And so because of that, we would say that these two ratios are in proportion. Okay, so we say that this ratio and this ratio are in proportion. And we would just write it with an equal sign in the middle. Okay, and the definition of what it means for ratios to be in proportion is basically just says that the fractions are equal. Okay, so if the fractions represented by the proportions are equal, then the two ratios are going to be in proportion. I think the book's definition is that you would have 9 times 2 is equal to 3 times 6. So it's like sort of a cross multiplication thing, but that's really the same definition as saying that the fractions are equivalent. All right. Let's do another example. This one we'll see like a part to whole ratio. So a cupcake recipe calls for 20 grams of sugar. The cupcake itself is going to weigh 80 grams. Let's say that we want to make a really big cupcake. Let's say that we have 30 grams of sugar to work with. We want to know how heavy will the cupcake made with 30 grams of sugar end up weighing. Okay. Don't ask me why we're only making one cupcake, but let's say that we're doing it. So our ratio that we start with is 20 to 80. And we want to get a ratio 30 to, and we could just use a variable here. We'll use x. And we want these two ratios to be in proportion. We want these to give us the same sort of thing. So how do we solve this? So we could solve it with the picture, or we could just sort of use fractions and cross multiply. And so do something like this. So if we want to do this, then we could just cross multiply everything. So we get 20x equals 30 times 80, or x equals 30 times 80 over 20. 3 times 8 is 24. Get some zeros on there. Divide by 20, and then I'll cancel out a 10 there, so this is equal to 120. So x would be equal to 120. And so our cupcake will end up weighing 120 grams.